Well, hey guys, I have some miniature LED bulbs to take a look at. These are the wedge base type bulbs that replace the, I believe they're called T10 incandescent, like this one here. Used in automotive applications, recreational vehicles, and probably even use them for solar panel applications. But I have several here to take a look at, 6 of them. And first I'll take a look at the power usage, some technical issues I have with them. Then I'll do a comparison of the brightness between a few of these here. Let's take a closer look at these bulbs. Well, I got this bulb and this bulb from m4products.com. $4 each, about 6 to ship. And the rest of them came from eBay, user Yitamotor. They seem to be the main seller on eBay for this type of light bulb. Free shipping from them, and the bulbs are really cheap. Depending on the bulb, they're around $1 each. You know, some less, some more, but you usually have to buy them in quantities. These bulbs here have LEDs all around to emit light in a sphere, and these have the LEDs on the end, and they shoot light out at give or take 120-degree angle. So depending on your fixture, you'd have to select which type of bulb you would need. This M4 Products bulb draws 0.78 watts. This bulb here, Yitamotor, draws 0.87 watts. This M4 Products bulb draws 0.49 watts, just about a half a watt. This one, it's just kind of just a bare circuit board. Well, this one draws 0.32 watts. This is a chip-on board, and what it is, it's the LEDs are kind of under this silicon type blob that has the phosphors inside, which emit the yellow light plus the blue from the LEDs, and you get a white colored light. It's kind of a wide band yellow emitting phosphor, and that along with the blue gives you the white light. So yeah, 0.72 watts. And this kind of interesting looking bulb has a lens, and it draws 0.55 watts. Okay, let's take a look at some of the issues I have with some of these bulbs right out of the package. Here's all the bulbs lit up in the same order that they're laid out on this paper. And as I decrease the voltage, notice that some bulbs go out and a couple stay on. This one here and this one, which is this one and this one. And the reason they do that is because of the way their arrays are set up. Well, what they've done, they set up in a series parallel array like this, and that's this bulb here that has 8 surface mount LEDs on it. Well, none of these bulbs have drivers. They're all using series parallel type arrays. And what happens is you have a forward voltage drop of around 3 to 3.2 volts with an LED, white LED, and 2 in series means 6.4 volts. Well, that leaves the resistor to drop the rest of the voltage. And if you have a 12.6 volt supply, that's about 6.2 volts. So that resistor dissipates all the extra heat instead of turning it into useful light. So, that's not ideal. It'd be better if they would use a 3 series type array like this. So you have a series parallel, and in the series strings there's 3 LEDs for a 12 volt supply. That leaves this resistor only having to drop about 3 volts. So less power is wasted in the resistor. So instead of turning electricity into heat, you have another set of LEDs, so you're turning more energy into light instead of heat. Of course, the LEDs do give off some heat, but it's better not to waste energy in the resistor as much. Of course, a driver would be better, but these small type LEDs do not have drivers, they only have dropping resistors. Okay, taking one of these LEDs apart. It's real easy. You just straighten out the leads and push it out of the base. The other ones are not quite as easy because I think they might have glued the LEDs in. Of course, that's just a circuit board, so there's nothing to take apart. But as you see, here's the LED array, and there's an 1/8 of a watt resistor. That's 180 ohms. So in this configuration with the 12.6 volt supply, that LED has to dissipate more than its maximum rating of 1/8 of a watt. It's dissipating closer to 1/4 of a watt. So it's just the crap that they do, the Chinese do with these cheap LED lights. Okay, well, I'm going to go on with the test here, the light test, comparison the light output, and select which bulbs I think are worthwhile. Okay, first on the left is the M4 bulb. This is the Yita bulb. This is advertised as being high brightness. And as you remember, the power consumption was similar. I think the Yita motors had about 1/10 of a watt more. Now if my camera would kindly focus, there we go. Oh yeah, the Yita motor bulb absolutely destroys the M4 products bulb. $4 bulb versus what are these, like $1.50 or something. Much brighter. The light is also whiter. It's not, this one is kind of a bluish white. This is more of a natural white. It's cool white, but it doesn't have that bluish cast. So this bulb is very good. Okay, on the left is the M4 products very small bulb with the surface mount LEDs versus the chip on board bulb. It has a similar design, except it's like I say, it's a chip on board, and there goes the Snickers. Alright. Here we go with the focus again. Okay. Looks like the M4 products bulb is a little bit brighter and whiter. The chip on board bulb is slightly bluer. They are pretty close in brightness. However, this bulb, as you remember, this one draws 0.72 watts, if I remember correctly, versus about 1/2 a watt. So this is using a lot more power, and it's not as good. Another problem with this bulb, it gets really hot. Now this is a small package, even though it's less than a watt, 0.72 watts dissipation, or I should say consumption. Some of that is turned into heat. This one gets hot to the point that it's starting to give off an odor. So this bulb is a fail. I would not recommend it. Again, on the left is the M4 Products bulb. This will always be on the left for the rest of these tests. Versus this, what I call the circuit board type bulb. This has a proper 3x3 array with 3 LEDs in series, like should be for 12 volt supplies. Let's see what it does. Very similar in light quality and brightness, about equal. Funny thing is, if you remember, this one drawed less than 1/3 of a watt, and this one was about a half a watt. So that confirms my earlier discussion about the arrays, how it's better to do it. In drawing only 1/3 of a watt, this one doesn't get very warm at all. So yeah, I actually do like these. Last but not least, versus the M4 Products bulb, is the Yeta Motors LED bulb that has the lens. I don't know if you can tell, but there's a couple of LEDs. They're supposed to be Samsung LEDs, so they're actually using a decent quality LED inside. I do like the design of it. But how does it work? Well, having the lens, it does kind of focus the light a little bit. So it does seem brighter than the other bulb, but it's not emitting light at as a wide angle, so they're probably quite similar in their light output. The one nice thing though, this light is warmer than the other ones. I mean, it's still a cool white LED, but it's more like a 5,000 Kelvin color temperature. So it's one of the nicest, well, it is the nicest light quality of all of these bulbs. So I do like this bulb as well. Well, that's a wrap. These are the LED bulbs that I think are the best out of those 6. And this one has 2 LEDs in series, so it has more of a wasteful type design, but still the light quality and the design of it, I still have to give it a recommendation. But these other 2 are, no problems with these at all. They're just very good. Well, that's it. Thanks for watching.